Now moving on to the first type of output file, the .MEANVALUE file. A very brief overview of this file. As mentioned, this file provides upstream and downstream station full passage integrated values for key thermodynamic and flow parameters. And the type of parameters that would be found in a typical mean line used by gas turbine and turbomachinery companies. And these parameters are flow weighted for the proper performance closure. So this output allows the user to make direct comparisons with mean line calculations that they may have done earlier in the design cycle. The next chart provides an example output table. Again, this is for the 3-row research turbine, and this here table provides the information for all 3 rows. And the table, first of all, starts off defining the sector and the case, which is given as, in this case, it was called row 1x through row 3x, and it was after 6,000 iterations, which is a fully converged solution. And you can see in the table, it gives the particular rows, row 1 through 3, and the next 2 columns here, which are now blocked, provides the upstream and downstream total flow. The next 2 columns provide the mass weight total temperature in the absolute frame of reference. Next 2 columns, the total pressure, again flow weight in the absolute frame. The next 2 columns, total temperature, but now in the relative frame. The next, the total pressure in the relative frame. The next column provides the total pressure loss across the airfoil row. The next column provides the efficiency based on a total-to-total basis and does not recognize cooling flows. And where there are cooling flows involved, there will be a different definition of efficiency, and that will be discussed in a later chart. The next chart provides an area average static pressure, upstream and downstream, and the last column provides the rotational speed. Moving on to the next chart, this chart shows the component overall summary for the 3-row turbine. And it provides the, first of all, it tells you the number of iterations, and then it goes through the flows, temperatures, and pressures, which I've covered before, except now it would be the upstream inlet to the component and the exit of the component. And what I've highlighted would be the total-to-total temperature and pressure ratios across the component. The efficiency, the inlet total to exit static pressure ratio is next, and then the efficiency based on the total pressure at the inlet and the static pressure at the exit. And this is another efficiency definition that is widely used in industrial turbines.